This is Dr. Lakshmi Narayana, Associate Professor, Department of Mathematics, Vardhaman College of Engineering. In this video, I am going to explain about test of significance for difference of means. Even we can call as Z-test for difference of means. If you see this, let x1 bar and x2 bar be the sample means of two independent large random samples of sizes n1 and n2 drawn from two populations having means mu1 and mu2 and standard deviation sigma 1 and sigma 2. So as per the working rules, we know it, the first working rule, null hypothesis. So thus we can write it as there is no significance difference between both means. That is, we can write as h0 colon mu1 is equal to mu2. Alternative hypothesis, we can write it as h1 colon mu1 not equal to mu2 and mu1 less than mu2 and mu1 is greater than mu2. Mu1 not equal to mu2 we can treat as two-tailed test, and mu1 less than mu2 is left-tailed test, mu1 is greater than mu2 is right-tailed test. So level of significance point of view, we will write it as a specified level of significance that we can denote it as alpha, and the test statistic is z is equal to x1 bar minus x2 bar minus delta divided by under root sigma 1 square by n1 plus sigma 2 square by n2, where n1 is the first sample size, n2 is the second sample size, and sigma 1 is the first sample standard deviation and sigma 2 is the second sample standard deviation, and the delta we can take it as mu1 minus mu2. And if sigma 1 square is equal to sigma 2 square, that we can take it as sigma square, then we can write the formula as z is equal to x1 bar minus x2 bar minus delta divided by sigma into under root, this is a whole root, under root 1 by n1 plus 1 by n2. And the critical value we can find out through normal table. Conclusion point of view, z calculated value is less than or equal to z table value, we will accept null hypothesis. Otherwise, we have to reject null hypothesis. And the rejection region of H0, as mentioned below, we will reject it at 1% level, 5% level, 10% level, as mentioned like this way. Z value is greater than 2.58 and Z value is greater than 1.96, Z value greater than 1.645, and a two-tailed test, we will reject H0. For left tail and right tail point of view, whenever the values are 2.33 at 1% level, 1.645 at 5% level, 1.28 at 10% level, we will reject null hypothesis. Now we'll discuss example based on difference of means. If you see this problem, a company claims that its bulbs are superior to those of its main competitor if a study showed that a sample of 40 of its bulbs have a mean life of 647 hours of continuous use with a standard deviation of 27 hours. While a sample of 40 bulbs made by its main competitor had a mean lifetime of 638 hours of continuous use with a standard deviation of 31 hours. Test the significance between the difference of means at a 5% level of significance. Now, based on this information, see, if you observe it, totally 40 bulbs and its mean time is 647 hours. And the corresponding standard deviation is 27 hours. And the second sample of 40 bulbs and the mean lifetime of lifetime is 638 hours and the corresponding standard deviation is 31 hours. So based on this one, we will assume it, this is as n1, this is x1 bar because it's a mean, this is sigma 1 standard deviation for the sample size, and this is n2 and this is x2 bar and this is sigma 2. Whenever n1, n2, x1 bar, x2 bar, sigma 1, sigma 2 is available, we can use difference of means concept. Now, as per the working rules, first of all, the first working rule is null hypothesis. We can write it as H0. H0 colon mu1 is equal to mu2. We can take it as mu1 is equal to mu2. Second working rule is H1, alternative hypothesis. H1 colon mu1, if you observe it, the superior I repeat. The alternative hypothesis. To write this statement is useful for us. A company claims that its bulbs are superior those of its main competitor. So in this, who is the main competitor? Who is the other one that you have to observe it? Alternative hypothesis. H1 colon mu1 mu2 based on the comparison we can write it as mu1 is greater than mu2. It is right tail test. And third one is level of significance. So as per the given specification, you should test at a 5% level of significance. The fourth working rule is test statistics. So that is Z is equal to x1 bar minus x2 bar divided by under root sigma 1 square by n1 plus sigma 2 square by n2 modulus. In this delta minus delta we can mention it, but where delta is equal to mu1 minus mu2 we can treat as 0. Okay, calculation point of view. The fifth working rule is calculation. So Z is equal to, as mentioned above, n1 is equal to 40 and n2 is equal to 40. x1 bar is equal to 647 and x2 bar is equal to 638 and sigma 1 is equal to 27, sigma 2 is equal to 31. Therefore, that Z is equal to, as we mentioned below, above 647 minus 638 divided by 27 whole square divided by 40 plus 31 square divided by 40. That is x1 bar minus x2 bar divided by under root sigma 1 square by n1 plus sigma 2 square by n2. Yeah, if you simplify that Z value, you will get it Z calculated value as 1.38 and Z table value at 5% level of significance under right tail test, you will get it as 1.645. Therefore, Z calculated value is less than Z table value. We accept H0. It means there is no significant difference between both means. Now we'll discuss one more example based on difference of means. If you see this problem, an investigator of the relative merits of two kinds of flashlight batteries showed that a random sample of 100 batteries of a brand A tested on the average 36.5 hours with a standard deviation of 1.8 hours, while a random sample of 80 batteries of brand B tested on the average 36.8 hours with a standard deviation of 1.5 hours. Test the difference between means at 1% level of significance. If you see this, the random sample, first sample size is n1 and corresponding mean is x1 bar and corresponding standard deviation is sigma 1, and another random sample of 80 batteries, that is n2, and means we can take it as x2 bar and standard deviation is sigma 2. So with n1, n2, x1 bar, x2 bar, we can apply Z test for difference of means, because here n1 n2 are greater than 30, so large sample test we have to apply. So as per the working rules, the first working rule is null hypothesis. We can denote it as H0, which is equal to mu1 is equal to mu2, and alternative hypothesis H1 colon mu1 not equal to mu2. We can apply two-tailed test. And third one is level of significance. Test at 1% level of significance as they mentioned above. Fourth one is test statistics. In that we can write as Z is equal to x1 bar minus x2 bar divided by sigma 1 square by n1 plus sigma 2 square by n2 under root. In this, delta is equal to 0. That's why we didn't mention here. Next, fifth working rule is calculation. that is z is equal to x1 bar minus x2 bar divided by sigma 1 square by n1 plus sigma 2 square by n2 in this, where n1 is equal to, as mentioned above, 100 and n2 is equal to 80, x1 bar is equal to 36.5 and x2 bar is equal to 36.8, sigma 1 is equal to 1.8 and sigma 2 is equal to 1.5. So all these values we can substitute in this formula, that is 36.5 minus 36.8 divided by under root 1.8 square divided by n1 is 100 plus sigma 2 square is 1.5 whole square divided by n2 is equal to 80 modulus. This if you simplify, you will get 1.23. So this is, we can treat as z calculated value, and z table value at 1% level of significance under two-tailed test is 2.58. Therefore, z calculated value is less than z table value. We accept H0. It means there is no significance difference between both means. Thank you.